Let's talk exponents. My job in this first page is simply to find what the exponent equals. Now, 3 to the 4th, it doesn't mean you take 3 times 4. It means you write 4 3's out and multiply them together. Find the product, the operations to multiply. It's multiplication, but you don't take 4 times 3 times 4. It means 4 3's multiplied together. So 3 times 3 times 3 times 3 is 81. Okay, negative 3 to the 6th power, so that means I have negative 3, use that as a factor 6 different times, and multiply. Now, so negative 3 times 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 negative 3. You get 729. Positive. The reason it's positive is because you have 6 negatives, so that's an even amount of negative factors, so then the product's positive. Okay, negative 2 to the 3rd power. Okay, so I find these products here. That means negative 2 times negative 2 times negative 2, negative 8. So this product was negative, and the reason why that was negative and that one wasn't is because there's an even number of negative factors. Here there's an odd number, so your product's going to be negative. And then with the fraction, don't let that jerk you around with your mind. You just write 1/7 out 4 times. And then you multiply the 4 1's, 1, 1, 1, 1. It's just going to be 1. So 1's the numerator. And 7 times 7 times 7 times 7 gives me the denominator, which is 2,401. Okay, that page is pretty easy, pretty much a walk in the park. Now it does start to get a little bit more challenging on the next page. Okay, so I need to simplify these exponential expressions, and I use these 3 boxes, but there's a couple things I need to do first. First, I have to have a dividing line, so I just underline the whole thing. Then I need to circle where my parentheses are at, and also the power that's outside. So this first parentheses has a power of 3. So any power that comes out of that needs to be multiplied by 3. And then we have a parentheses here with a 2 outside. That's a 2. Okay, now for the numbers on top, the big numbers that are not circled, I have a number 2 and a number 7. So I write 2 times 7, and then I have a letter X. Now I know you have 2 X's, but we just write X just one time. Okay, so 2 times 7 times X. Those are my bases. So now let's look at our 2. Now our 2 needs a direct exponent. It's to the 1 power, okay? So that's in the parentheses. It's in the circle, so I got to take the 1 times the 3. And 1 times 3 is 3. So it's 2 to the 3rd power. Now for 7, right here, it needs a direct power, so it would be 1. And then I take the 1 times the 2. 1 times 2 is 2. Okay, now for X. Now we have 2 X variables. Here's my first one, okay? It's to the 5th power, but it's in the circle, so I have to take 5 times 3, and 5 times 3 is 15. Now with my other X, I use one of my rules, okay? This X is on top of the line, okay? So since it's on top of the line, we add, okay? When it's on the bottom, you minus, but we're going to add here. And then that X is to the 7th in the circle, so 7 times 2 is 14, okay? So I have 15 plus 14. So 15 plus 14 is 29. So that X is to the 29th power, okay? Now, let's circle all of these bases and powers, okay? 2 to the 3rd, 7 to the 2nd, X to the 29th. Now, in the second box, either we keep it, if the little power number is positive, it stays, okay? And the little power number is positive, it stays. Stay. And the 29th is positive, so it stays. Now, stay. that means it stays on the same side. So it's on top, it stays on top. So 2 to the third. And then this stays, it's on top, it stays on top. Okay. And then this x stays, it's on top, it stays on top. Now, if the power is negative, it's got to go to the opposite side. Okay. Opposite of top's bottom, opposite of bottom's top. Okay, so now, right here, I figure out what I can. Okay, 2 to the third would be 2 times 2 times 2. And 2 times 2 times 2 is 8. So I replace the 2 to the third with its equal, which is 8, times, and then 7 to the second, that would be 2 sevens multiplied, 7 times 7, and that's 49. Okay, so 7 to the second now turns into 49. And I can't replicate a base, you know, I can't clone a base. I can't clone a base if it's a variable, so that will stay x to the power of 29, okay? X to the 29. Now, 8 times 49, we have to do that operation. 8 times 49 is 392, so I cross this out and I put 392. So my answer is 392 times x to the 29th power. Okay, now here's my next one. Here's my dividing line. Now I don't have a parentheses to circle, okay? So I don't need to multiply the exponents. So what are your bases? You have a 4 on top, and on bottom you just have more number 4s. Now since I already wrote 4 on top, I'm not going to write it again on bottom, okay? So 4 is the only base I have to worry about. Now here's my first 4. It's to the third. There's not in a circle, so I just write 3 down. I don't need to multiply. And then here's my next 4, but it's on bottom, so I'm going to minus, and I would minus just 2. And then I have another 4 that's also on bottom, so since it comes from the bottom, we use the minus operator and 5. Again, I am not multiplying like I did here because I don't have the parentheses. So I take 3 minus 2 minus 5, and I get negative 4. So I cross these out and put negative 4. So I have 4 to the negative 4th power. So this is the only base I have, okay? And it's negative, so that will not stay. That'll go opposite, okay? So it's on top. What's the opposite of top? The opposite of top's bottom. So that big 4 goes to the bottom, and then its negative 4th power now becomes positive 4. And then to cover the top of the fraction, we put a 1, okay? So 1 will stay just 1, and 4 to the 4th I clone, okay? 4 times 4 times 4 times 4. So 4 times 4 times 4 times 4 is 256, okay? So I replace the 4 to the 4th with 256. So that's your answer, 1 over 256. Okay, now in the next problem, first I look for my dividing line. I have 2 of them, but in multiplication, what I can do then is extend the line so it goes through the whole thing. And I also have a parentheses I want to circle, which is right here. Okay, so on top I have 3, the number 3, and the letter x. Remember, I don't look at the numbers in circles. Those are exponents. So when I'm setting this up, I write number 3 and letter x. Now beneath the line we have the number 4. We got the letter x, but I already have the letter x on top, so don't put it again. And then we have the letter b. Okay, now we can decide what powers become here. So 3 is to the 1, but it's not in the circle, okay? So I just write 1 down, okay? Now 4 would be to the 1, okay? But again, it is not in the circle. Don't take 1 times 10. I did not make a circle here. It's just 1, okay? So it's 4 to the 1 power. Okay, now let's look at our variables, x. Okay, the first x I have is to the 3rd, but since that's in the circle, we take 3 times 7. Okay, So 3 has to be multiplied by 7 before I write the exponent. It's 21. And then here's another x. Now, is that on top or bottom of the line? It's on bottom, so we're going to subtract. And we just subtract 10. It's not a circle, so I just write 10 down. So I take 21 minus 10, and that's 11. So it's going to be x to the power of 11. Okay. All right, now the b. B needs a direct power. I put a 1 there. Circle it, and it's in the circle, so I take 1 times 7. 1 times 7 is 7. Okay. So here are my factors. 3 to the first, x to the 11th, 4 to the first, and b to the 7th. Now, is that a negative? No, it's positive, so it stays where it's at. Is that a negative? No, it's positive, so that stays. Is 1 a negative? No, it's positive, so that stays. And that stays. So everything stays where it's at. So 3 to the first is on top, it stays on top. X to the 11th is on top, it stays on top. 4 to the 1 is on bottom, it stays on the bottom. At b to the 7th is on bottom, and it stays on the bottom. Okay, and then 3 to the first, that just turn into 3 because you just clone. You wouldn't really clone; it'd just be 3. So, and then the variable can't be cloned; it stays x to the 11th. Then 4 to the first would just be 1 4. So I just replace 4 to the first with the number 4 and times b to the 7th. Now you don't have to do anything with 3 and 4, okay? Because they're on opposite sides of the line. See, up here they were on the same side, so I did the multiplication operation. But here when they're on opposite sides, we're just going to leave it, and that's simplified. So 3 times x to the 11th over 4 times b to the 7th. Okay, then in my next problem, find your dividing line. It'd be right here. And circle where you have a parenthesis, so that would be here, but not here. Okay, it's just around here. So anything coming out of this has to be multiplied by 3 before I write it down here. Okay, so what do I have for bases? I have the number 3, I have the letter x, I have the letter y, and then I got the letter x again, but since I already wrote the x first, I don't need it again. So 3 would be to the 1, and it's in the circle, so I take 1 times 3. So that's 3 to the third. And then x is, well, there's 2 of them. Here's my first x. It's to the negative second power, but it's in the circle, so I got to take negative 2 times 3. Negative 2 times 3 is negative 6, so I write negative 6 now. And then there's another x here. Is it on top of the line or on the bottom of it? It's on top, so we're going to add, and we just put 5 down. We don't multiply 5 by anything. It's not in the circle. So I add negative 6 plus 5, and I got negative 1. So x is to the power of negative 1. Okay, then the y. Y is to the second. It is in the circle, so I don't write 2 down. I got to take 2 times 3. We have to distribute 2 to 3, and that's 6. Okay, so now circle your factors. We have 3 to the third, x to the negative first, and y to the sixth. So this is a positive power, so it stays. This is a negative power, that's got to be opposite. And this is a positive power, so it stays. So 3 to the third's on top, and it stays on top. The x is a negative, so what's the opposite of the top? The bottom. So the x goes into the bottom, and the negative 1 turns into a positive 1. When it goes opposite, its exponent turns from a positive power to a negative power to a positive power. And then y to the sixth stays, so it's on top, and it stays on top. Okay, so what can I clone here? 3 to the third I can clone. 3 3's, and then you multiply the 3's together. So 3 times 3 times 3 is 27. Okay, so that's replaced with 27. And then the variables really can't be cloned. They just put those where they belong. Okay, and they don't switch places. After you place them here, they stay in the same place. So I have 27 times y to the sixth power over x to the first. or just X. Okay, scientific notation. You took a look at this yesterday. Remember how that looks. It's some number times 10, and then we have a power on the 10. Now here's my decimal to start with, okay? And I go mark off the first non-zero number. That doesn't work. That's 0. 0, 0, 0, 0, 0, 2. So the decimal has to be moved so it's between the 2 and the number afterwards, 7. It'd be right here. Well, you have to go this way, okay? This direction. That is right. And if I'm moving a decimal to the right, then the exponent's going to be negative, okay? So I need to put a negative right there. Now move it. 1, 2, 3, 4, 5, 6. So now my decimal's there. So my answer, we have a decimal at 2 in front and then 7.3 behind it. So 2.73 times 10. We have a negative power because we moved to the right, and I count the digits between decimals. So 1, 2, 3, 4, 5, 6. 2.73 times 10 to the power of negative 6. Now this is very easy. You just use your calculator. 2.83 times 10 to the 8th power. So 2.83 times 10, hit the power key, and then it takes it from scientific to standard, okay? So the decimal's at the end, so I'm not going to put it in the answer. 283,000,000. And please put commas, since your decimal's here, put commas every 3. 283 million. Okay, then you have some story problems. They're kind of like yesterday, but there's one main difference. A farmer bought a tractor of $30,000, and that's the original price, the beginning price. The value of the tractor has been decreasing at a rate of 18% per year. How much is the tractor worth 16 years from now? So we have 2 units, okay? So remember what we do. Whenever we have 2 units, we want to make a side box. Don't make the other boxes. You're not going to need them. I'm going to tell you why here in a second. You have dollars and years, okay? The years, the time is X, okay? And then that's Y. And then put per year, and then dollars per year. Well, you see per year here, but it's not a dollar amount, it's a percent amount. So it's 18%, okay? When it's a percent, we're going to write, and it's every year. By the way, put down here how many years you have, okay? You have 16 years, okay? So when it's a percent every year and you have more than 1 year, you want to set up the beginning, or the original, sorry, times the percent equals the new, okay? Now the original we know, we're going to do the percent first, okay? So I take 100%, and it was decreasing by 18%, so we would minus 18%, and that is 82%, but remember to divide it by 100, okay? So I take 82 divided by 100, and that's 0.82. But unlike yesterday, you just left that because it didn't say per year. Here it says per year, and there's 16 years. So we're going to take that to the power of 16, okay? And then $30,000 is the original. So 30,000 goes here. We're going to put X for the new. So I multiply. I just use my calculator. I take 30,000, multiply by 0.82. To do the power, you hit the caret button. It's the upside down V, and that takes that to the 16th power for you, okay? And that's my answer, $1,253.55, okay? So $1,253.55. Okay, now my next one. A family buys a house for $150,000. The value increases at a rate of 8%. Find the home's value after 5 years. So we have 2 units, dollars and years. I've underlined both of them, okay? So dollars and years. So again, the time unit's the X, and then that's your Y. So per, it's always per year. or per month, whatever the unit is, dollars per year. And per year it says 8%, okay? So that's a percent. So what I'm going to want to do here is say, okay, it happens every year, the 8% does, so how many years do I see? I see we have 5 years, okay? So now, since I had a percent, I'm not going to make a graph. I'm going to set up my original times percent equals new. So original, percent, and new. Okay, so I know how to do my percent just like I did. Now it's an increase in big caps, so you add 8%, and that's 108%. Now remember to divide it by 100. So 108 divided by 100 is 1.08. Now that happens every year though, and there's 5 years. So to repeat the multiplication, we use a power and we put 5. Okay. Now I know you didn't do that yesterday because it didn't say per year, so it just happened one time. Okay, but here it's per year for 5 years, and then 150,000 is the original. And then that's my new. And I can just find that, simply multiply that on my calculator. 150,000 times 1.08, hit your caret button, 5, and that's my answer. Okay, here's the decimal. So you got 21 cents, okay? That's supposed to say a dollar sign right there. And I have 220,399, so $220,399. Okay, that's all I have on that one. Now in the other one. Operations with expressions. Now, here we have a plus sign, so no rainbows. We go straight to our blanks. X second is the highest power you have the x to, plus blank x plus blank. Then you go find your x seconds. You've got 8 and negative 11. So you plus those. 8 plus negative 11 is negative 3. So I have negative 3x to the second powers. Now look for your regular x's. You have negative 3 and positive 2. So I take negative 3 plus positive 2 means just plus 2, so you get negative 1. Okay, then you're looking at your constants, so ones without variables. So I have negative 10 and negative 7. So negative 10 plus negative 7, negative 17. Okay, and that is simplified. Okay, on my next problem, 6x to the third plus 12x second, put a 1 in front of that x, and now you have a minus, okay, 15x second plus 7x minus 0. So this time the highest power is to the third, so I go blank x to the third plus blank x second plus blank x plus blank. So x to the third, I have 1 in this polynomial, but not in this one. So I just take 6 minus 0. That would be 6. Cross it out. Now x second, we've got 12x to the second in the first polynomial and 15x to the second here. So I take positive 12 minus 15, negative 3. Okay, then x. I've got negative 1x and positive 7x. So I take negative 1 minus positive 7, or just 7, so negative 8. Okay, and then constants. Well, I don't have a constant here, so I enter in 0 minus negative 8. Remember, 0, take away a negative is just like a plus, okay? So that's 8. There's your polynomial. Okay, now, starting on these next problems, you need rainbows, okay? So, I have this outer thing, okay? And you distribute the 5 to everything. So 5 to 2, 5 to negative 3, 5 to 5, and 5 to negative 1. How many rainbows did I just draw? I just drew 4. So I write 5x to the 4th power 4 times. Oh, off to the side, okay? And then I have 2x to the third in my first. And then my second factor is negative 3x to the second. Remember to look at the negative. And then positive 5x. And then negative 1. Okay, now before we find these products, we need to make sure all x's have powers. So that's 4 and 3, that's good. 4 and 2, 4 and 1, then 4 and then nothing because there's no x there. So I take 5 times 2 is 10. Okay, we times the big numbers, and then on the x, we add the exponents. It's like they're on the same side of a line. 4 plus 3 is 7. Okay. 4 plus 3, cross it out, put 7. 10x to the 7th. Okay, now in the second product, take 5 times negative 3, negative 15. And then as far as the x's go, I take 4 plus 2. 4 plus 2 is 6. Okay, and then 5 times 5 is 25. And then on x, we take 4 plus 1, which is 5. Okay. And then I take 5 times negative 1, which is negative 5. Then on the x, we just have the 4, because I don't have an x there, so it's just to the 4th. Now I have 7th power, 6th power, 5th power, 4th power. Those are all different, so I don't need to write the spaces. I just need to write these terms with addition operators between them. So 10x to the 7th plus negative 15x to the 6th plus 25x to the 5th plus negative 5x to the 4th. Okay, and all the powers are different, so that's your answer. Okay, now my next problem. Now, if there's no sign between the parentheses like there was here with the plus and the minus, then it's multiplication, okay? And to multiply, you need rainbows. Put a 1 in front of that x. So you circle the 3, and then you distribute 3 to 1 and 3 to 5. Not 3 to negative 7, because that's in the same parentheses. Never draw a rainbow into the same parentheses. So I wrote 2 rainbows. So 3x, 3x, and I'm going to times it by 1x, and I'm going to times it by 5. And then I can forget that. Now I distribute the negative 7 to each one. So there's 2 rainbows. So negative 7, times and times, 1x and 5. Okay, now we go into our procedure. So x, 1 and 1, x 1, then nothing, nothing, and x to the 1, and then nothing, nothing. So 3 times 1 is 3, and then on x I take 1 plus 1, and that's 3x to the second power. That's a 2 there. Then 3 times 5 is 15. And then x, it would just be to the 1. Negative 7 times 1 is negative 7. Then on x, it would just be to the 1. And then negative 7 times 5 is negative 35. Now in this one, you have a second power, a first power, and nothing. So these are like terms here because they both have the same power. So I go blank x to the second plus blank x plus blank. So x second, you got 3. For x, that's these two, the x to the first. So we add those. We take 15 plus negative 7, and that's 8. Okay, and then we have our negative 35 as the constant. And there's my product. Okay, now on this next one, again, it's multiplication. So I circle 3x, I distribute 3 to 2, 3 to negative 5, and 3 to 6. How many rainbows just did I draw? I drew 3. So I write 3x 3 times, okay? And then I'm going to multiply them by these 3 terms. 2x to the second, negative 5x, and positive 6. And that's done, and now I do the same thing with the negative 2. So negative 2, again, 3 rainbows. And I'm going to distribute it to the same 3 factors, 2x to the second, negative 5x, and 6. So that's a 1 and a 2. That's a 1 and a 1. That's a 1 and nothing. That's nothing and 2. That's nothing and 1. And that's nothing and nothing. Okay, now I find my products. You just multiply the big guys. 3 times 2 is 6. And then the little guys we add. 1 plus 2 is 3. 6x to the third. Okay, 3 times negative 5 would be negative 15. And then on x, 1 plus 1 is 2. Okay, then right here, I don't have anything. Or no, 3 times 6 is 18. And then on x, you just got the 1. Okay. Now, negative 2 times 2 would be negative 4. Then on x, you just got the 2. So x to the second. Negative 2 times negative 5 is positive 10. Then on x, you just got the 1. And then negative 2 times 6 is negative 12. Now you got a third power, a second power, a first power, and then another second power and another first power. So because I have some of the powers that are the same, we're going to want to write our blanks out. So blank x to the power of 3 plus blank x second plus blank x plus blank. So for x to the third, I just have that once with 6. Okay, and that's done. For x second, I have negative 15 and negative 4. So those are x to the second, so they're like terms. They're added. Negative 15 plus negative 4 is negative 19. Okay, now for x, that's looking for the first power. So I have 18 and 10. 18 plus 10 is 28. And then for the constant, I just have the negative 12. Okay, so this is how you multiply. Okay, now in the next problem, I'm going to create a multiplication problem out of this. I don't want to have the 3 boxes because there's a big minus sign in there. Okay, whenever you have a minus or plus operator, you want to get rid of your exponents and simply clone another parentheses that has the exact same thing. Okay, now I'm ready. It's multiplication. So I have 4x. 4x. So 2 rainbows. So 4x, 4x. And I multiply by 4x and negative 5. So that's done. Now I distribute the negative 5. So negative 5, negative 5. And we're going to multiply that by the same 2 factors, 4x and negative 5. Okay, so 1, 1. 1 and nothing, nothing and 1, and then nothing. So 4 times 4 is 16. Now on x, you take 1 plus 1, which is 2. 4 times negative 5 is negative 20. Then on x, you just have 1 here to the first power. That's also going to be negative 20. And for x, just right here, that's to the 1 power. 5 times negative 5 is negative 25. Okay, so I have a second power, a first power, a first power. So some of them are the same. So I make my highest x power, blank x second, plus blank x plus blank. So for x the second, I have 16. For x, I'm looking at first powers right here, and I add those, negative 20 plus negative 20, and that's negative 40. And then for constants, you have your negative 25. Okay, and then this one's another multiplication. Okay, so you circle your first term and distribute it into the second parentheses. So you just drew 2 rainbows. So 4x, 4x, and you're going to multiply by 4x and by 2. Okay, that's dead. Now negative 2. So I write negative 2 down twice, and I multiply that by the same 2 factors, 4x and 2. So 1, 1, 1 and nothing, nothing and 1, and then nothing. Okay, so I take 4 times 4 is 16. Then on x, 1 plus 1 is 2. 4 times 2 is 8. And then x to the 1. Negative 2 times 4 is negative 8. And that's x to the 1. That's negative 4 with no x. Okay, you got some powers that are the same. Okay, those two. So blank x second plus blank x plus blank. So I've got 16x to the second powers. Now for x, I add 8 to negative 8, but then a funny thing happens. It's 0. So if it's 0, you just take out that term, okay? And then you have negative 4. Okay, and then the last problem. A garden has dimensions of 15 by 17 feet. You're going to build a rectangular border that's the same on every side. Write a polynomial expression area that combines the area of the garden and the border. So here's what I do. 15 by 17 is the middle dimensions, 15 and 17. Now, measure your dimensions like this, okay? Make a line that matches up with the bottom of the rectangle, and then you mark where the middle starts and stops. And you know from here to here is 15. And then I don't know the edges, okay, so I'm going to call them both x because they are the same. And then I do the same with the width, okay? Mark where the middle starts and stops, and from here to here straight across I see 17, and then x and x, okay? So you got to do that first. Now, the area. Area is multiplying two parentheses. It is taking the length multiplied by the width. The length is the bottom. So how many x's do you see on bottom? Well, here and here, that's 2. So that'd be 2x plus 15. It's 2x, not x to the second. In the width, there's 2 x's and a 17. So 2x plus 17. And now I forget that this is even a story problem and do my rainbows. So 2x. So I drew 2 rainbows. 2x, 2x. And I'm multiplying that to 2x here and 17. Okay, now I repeat the process with 15. So 15, 15, and I will be multiplying by the same two things, 2x and 17. Okay, so 1, 1, 1, 1, nothing. So 2 times 2 is 4. And on x, 1 plus 1 is 2. 2 times 17 is 34, and then it'd just be x to the 1, because that's the only x I have. 15 times 2 is 30, x to the 1. Then 15 times 17 is 255. Okay, now I obviously got some powers that are the same with these two. So I line up my blanks. Blank x to the second plus blank x plus blank. So for x to the second, I have 4. For x, I got 34 plus 30, and that makes 64. And then I have 255 for my constant. Now circle that. Now, part B, use your expression to calculate the combined area of the garden and border if the border has a width of 8 feet. Now, what that is telling me, the border is the x. So now I can put 8 feet in for x. So put a parentheses around these. Just replace your x's with parentheses. So you got 4 parentheses to the second plus 64 parentheses, no power with that one, and then plus 255. And all you're going to do is put 8 inside of these. And your calculator can figure out the answer. So I got 4 parentheses, 8, close it, second power's here, and then keep going, plus 64, parentheses 8, but I won't do a power on that, and then plus 255. And that gives me 1023, and that's the area.